Hello guys. What if I told you that scientists can now tell us exactly what happened in the first terrifying minutes when the dinosaurs went extinct? Not just the general story, but the precise details of every single second of the most catastrophic day in Earth's history. 66 million years ago, on what seemed like an ordinary morning, a mountain-sized asteroid traveling at 45,000 miles per hour was about to end the age of dinosaurs forever. But here's what will blow your mind. We now know exactly what those first minutes looked like, second by second, thanks to incredible new research and technology. Today we're going to experience the most detailed reconstruction ever created of the day the dinosaurs died. We'll witness the impact that released more energy than 1 billion atomic bombs. We'll see how the entire planet caught fire in a single day. And we'll discover why only a handful of species survived the most devastating extinction event in Earth's history. By the end of this journey, you'll understand exactly how 165 million years of dinosaur dominance came to an end in just a few terrifying minutes. So let's travel back 66 million years and witness the day that changed everything. This is the late Cretaceous period, and Earth looks nothing like it does today. The climate is dramatically warmer. There's no ice at either pole. Palm trees grow in Alaska. Sea levels are 200 feet higher than today. The Yucatan Peninsula, where our story unfolds, is covered by a warm, shallow tropical sea teeming with life. Massive marine reptiles patrol these waters. Mosasaurus, ocean predators 50 feet long with jaws that could crush a car, glide through coral reefs. Giant sea turtles, some the size of small cars, navigate the crystal clear waters. Ancient sharks and rays populate the seafloor. On the nearby landmasses, the last great dinosaur civilizations are thriving. Massive triceratops herds graze in coastal plains. Towering Tyrannosaurus rex, each weighing 7 tons, rule as apex predators. Duck-billed Edmontosaurus gather in herds thousands strong, their calls echoing across vast wetlands. To understand the magnitude of what's about to happen, we need to picture the world as it existed 66 million years ago. This is the late Cretaceous period, and Earth looks nothing like it does today. The climate is dramatically warmer. There's no ice at either pole. Palm trees grow in Alaska. Sea levels are 200 feet higher than today. The Yucatan Peninsula, where our story unfolds, is covered by a warm, shallow tropical sea, teeming with life. Massive marine reptiles patrol these waters. Mosasaurus, ocean predators, 50 feet long, with jaws that could crush a car, glide through coral reefs. Giant sea turtles, some the size of small cars, navigate the crystal clear waters. Ancient sharks and rays populate the seafloor. On the nearby landmasses, the last great dinosaur civilizations are thriving. Massive triceratops herds graze in coastal plains. Towering Tyrannosaurus rex, each weighing 7 tons, rule as apex predators. Duck-billed Edmontosaurus gather in herds thousands strong, their calls echoing across vast wetlands. In the forests, 40-foot-long Alamosaurus use their enormous necks to strip leaves from towering conifers. These are some of the largest land animals that have ever existed, and they've been the dominant life form on Earth for over 165 million years. But 200 million miles away, in the asteroid belt between Mars and Jupiter, their doom is already approaching. A chunk of rock and metal 6 miles wide has been knocked from its stable orbit by a cosmic collision. This isn't just any space rock. It's composed of dense materials including nickel and iron, making it incredibly destructive. This killer asteroid has been traveling through the vacuum of space for millions of years, gradually pulled toward Earth by our planet's gravity. It's moving at an unimaginable 45,000 miles per hour, 20 times faster than a rifle bullet. At this speed, it could cross the entire United States in just 4 minutes. The dinosaurs below have no idea that their planet is pulling their destruction toward them at increasing speed. They continue their daily routines, hunting, grazing, nesting, raising young, completely unaware that in just a few hours, their 165 million year reign will come to a sudden and violent end. Let's now focus on the final hour before impact. This is where our story becomes incredibly precise, because scientists can now track the asteroid's approach with remarkable accuracy. 60 minutes before impact, the asteroid enters Earth's sphere of gravitational influence. At this point, our planet begins to accelerate the space rock even faster. The dinosaurs below are unknowingly pulling their own extinction toward them with Earth's gravitational field. If any dinosaur with exceptional eyesight looked up at the night sky at this moment, they might notice what appears to be a new star. This bright point of light is actually the approaching asteroid, still millions of miles away but already visible due to its enormous size, and the sunlight reflecting off its surface. 45 minutes before impact, the asteroid is close enough that its motion against the background of stars would be detectable to an extremely observant creature. It appears as a bright object, perhaps as bright as Venus appears to us today, drifting slowly across the celestial canvas. 30 minutes before impact, the space rock has accelerated to over 47,000 miles per hour due to Earth's gravity. Any dinosaur looking directly at it would see it as bright as a full moon, but moving perceptibly against the star field. Still, there's no way for these creatures to comprehend what they're witnessing. 15 minutes before impact, the asteroid enters the outer reaches of Earth's atmosphere, about 600 miles above the surface. At this altitude, it encounters the first wisps of atmospheric gas. Most meteors would begin to slow down and heat up at this point, but this mountain-sized object is so massive that the thin upper atmosphere has virtually no effect on it. 10 minutes before impact, now just 450 miles above Earth, minus, closer than the distance from New York to Washington, D.C., the asteroid begins to interact more significantly with the atmosphere. It starts to compress the air in front of it, creating the first signs of the devastating shockwave that will soon follow. 5 minutes before impact, at 125 miles altitude, some of the more sensitive dinosaurs might actually begin to sense that something is wrong. The asteroid's approach is creating subtle gravitational and atmospheric disturbances. Flocking birds feel an inexplicable urge to take flight. Herd animals become restless without understanding why. 3 minutes before impact, the asteroid punches through the mesosphere at 120 miles altitude. The air in front of it is now being compressed to incredible densities. When you compress air rapidly, it heats up dramatically. The temperature in front of the asteroid reaches thousands of degrees, creating a growing ball of superheated plasma. 2 minutes before impact, at 90 miles altitude, the asteroid is surrounded by a sheath of glowing plasma, hotter than the surface of the sun. This creates a blazing trail across the sky that would be visible for hundreds of miles in every direction. The entire atmosphere begins to glow with an unnatural light. 1 minute before impact, just 45 miles above the surface, the asteroid is now screaming through the stratosphere. Any dinosaur that happens to look up sees something that has never been witnessed before in Earth's history. The entire sky appears to be on fire. A trail of plasma and superheated air stretches across the heavens like a sword of light. 30 seconds before impact, the asteroid reaches the troposphere, where weather occurs. It's now just 6 miles above the Yucatan Peninsula. The pressure wave preceding it begins to affect the shallow sea below. The water's surface starts to churn and ripple from the atmospheric disturbance above. 10 seconds before impact, 2 miles above the surface, the superheated air around the asteroid begins to vaporize the top layer of the shallow sea. Water that has existed peacefully for millions of years instantly converts to steam. The temperature at the impact site reaches several thousand degrees before the asteroid even arrives. 5 seconds before impact, 1 mile above the surface, marine life directly below might of ancient corals, fish, sea turtles, are killed instantly by the wall of superheated air that precedes the impact. The water itself begins to break apart at the molecular level. 3 seconds before impact, the asteroid is now so close that you could see its scarred, irregular surface if you had superhuman vision and could somehow survive the radiation and heat. This mountain-sized chunk of rock and metal is about to release more energy than all of Earth's volcanoes erupting simultaneously for 1,000 years. 1 second before impact, the moment of truth arrives. In the next second, 165 million years of dinosaur evolution will come to an end. At exactly 0.00 seconds, the asteroid strikes the shallow sea covering the Yucatan Peninsula, with the force of 10 billion atomic bombs exploding simultaneously. But to truly understand what happens, we need to break down this single second into tiny fractions and examine each moment. Microsecond 1. The front edge of the asteroid makes contact with the sea floor. The impact generates pressures 100 million times greater than normal atmospheric pressure, pressures that exist at the cores of giant planets. At the point of contact, matter behaves in ways that seem almost magical. Microsecond 1. The intense pressure and heat instantly transform the atomic structure of everything at ground zero. Limestone becomes marble. Quartz transforms into rare minerals that only form under these extreme conditions. But most shocking of all, thousands of tons of rock and water don't just melt, they vaporize instantly, skipping the liquid phase entirely. Microsecond 50. A sphere of vaporized rock and water is expanding outward from the impact site at over 30,000 miles per hour. This isn't just hot gas, it's plasma, with electrons stripped from their atoms by the violence of the collision. The temperature exceeds 20,000 degrees Fahrenheit. Microsecond 100. The asteroid itself is being destroyed. This mountain-sized chunk of rock that traveled peacefully through space for millions of years is being annihilated in microseconds. The front portion has been completely vaporized, while the rear section continues plunging downward. Millisecond 1. The impact cavity is now half a mile wide. The walls aren't solid anymore. Under these extreme conditions, rock flows like water, granite moves like honey. The very concept of solid rock has ceased to exist at ground zero. Millisecond 5. Something incredible happens. The impact has dug so deep, nearly 20 miles into the Earth's crust, that it's approaching the boundary between the crust and mantle. The asteroid is literally trying to punch a hole through the Earth's outer shell. Millisecond 10. The Earth fights back. The immense pressure at these depths causes a rebound effect. A column of crushed, melted and vaporized rock begins to rocket upward from the center of the impact crater at over 1,000 miles per hour. Millisecond 50. This column of debris will rise higher than Mount Everest, carrying with it fragments of the original asteroid, pieces of the seafloor, and exotic minerals created by the tremendous impact pressures. Some of this material is moving so fast it will escape Earth's gravity entirely. Millisecond 100. The impact cavity reaches its maximum size, -5 miles wide and 20 miles deep. If you could somehow survive and look into this crater, you would see walls of rock glowing like lava, and temperatures at the bottom approaching 30,000 degrees Fahrenheit. Millisecond 500. The rebound column of debris punches through the atmosphere and into space itself, rising 25 miles above the surface. For a brief moment, pieces of the Yucatan seafloor are floating in the vacuum of space, 66 million years before humans even exist. At exactly 1.00 complete, the immediate destruction at ground zero is complete. The asteroid has been entirely obliterated. What remains is a crater larger than Connecticut, filled with molten rock at temperatures that would vaporize steel. But the global catastrophe is just beginning. A seismic shockwave carrying the energy of a magnitude 11 earthquake is racing through the Earth's crust at 15,000 miles per hour. An atmospheric shockwave of superheated air is expanding outward at over 2,000 miles per hour, and the column of debris blasted into space is beginning its deadly rain back to Earth. The dinosaurs across North America still don't know what has happened. The light from the impact is just reaching their eyes as a flash brighter than lightning on the southern horizon. The sound hasn't even begun to travel to them yet, but their world has already ended. They just don't realize it yet. Now we witness how the destruction spreads from ground zero across an entire continent. In the next 5 minutes, the asteroid impact transforms from a local catastrophe into a global extinction event. 5 seconds after impact, the seismic shockwave racing through the Earth's crust reaches 75 miles from ground zero. Any dinosaurs in this range experienced something unprecedented in the history of life on Earth. The ground beneath their feet doesn't just shake, it liquefies. The seismic energy is so intense that solid rock behaves like water. Massive sauropods that have stood firmly on their legs their entire lives suddenly find themselves sinking into what was solid ground moments before. The Earth itself has turned to quicksand. 10 seconds after impact, the atmospheric shockwave, a wall of compressed air heated to thousands of degrees, begins its deadly advance. This wave is traveling at over 2,000 miles per hour and carries with it vaporized rock, superheated steam, and fragments of the original asteroid. Meanwhile, something incredible is happening in the upper atmosphere. The debris blasted into space begins its return to Earth. But these aren't just rocks falling, they're incoming meteorites, heated to incandescence by their passage through the atmosphere at 25,000 miles per hour. 15 seconds after impact, across the entire sky above North America, thousands of blazing streaks of light appear. Each streak is a piece of the Yucatan seafloor that was blasted into space and is now returning as a massive shooting star. The sky itself begins to glow as if someone had turned on a giant oven. 20 seconds after impact, the atmospheric shockwave reaches the Texas coastline. Any dinosaur in its path dies instantly from the 3,000-degree air, hot enough to melt copper. Trees spontaneously combust before the shockwave even reaches them. Coastal swamps that have existed for millions of years are incinerated in seconds. 30 seconds after impact, the seismic wave reaches present-day Texas. The ground shaking is so violent, it literally throws 100-ton sauropods into the air like toys. When they crash back down, the landscape has been completely transformed. Hills have collapsed, valleys have been filled, and new geological features have been created in seconds. 45 seconds after impact, dinosaurs as far away as Colorado see a second sun appear on the southern horizon. This new sun is so bright, it hurts to look at directly, but they have no idea what they're witnessing. Their brains simply cannot process something this far outside their experience. The returning debris from space has intensified into a continuous rain of fire. The upper atmosphere is so full of incoming meteorites that the sky would be brighter than day even at night. Each piece of debris generates tremendous heat through friction, and this heat is beginning to ignite vegetation across the continent. 1 minute after impact, the sound barrier created by the initial impact reaches dinosaurs over 1,000 miles away in present-day New Mexico. They hear something that has never existed on Earth before, a sonic boom so loud it would rupture human eardrums, carrying enough energy to shatter rock formations and trigger avalanches. 1 minute 30 seconds, the atmospheric heating from the returning space debris reaches a critical threshold. Across thousands of square miles, forests that have grown undisturbed for millions of years burst into flame simultaneously. This is the beginning of a global firestorm that will eventually circle the entire planet. 2 minutes after impact, the seismic shockwave has traveled 1,800 miles from the Yucatan. Dinosaurs in present-day Canada are experiencing earthquakes more powerful than anything in recorded history. But these aren't random earthquakes. The impact has set the entire planet ringing like a bell. Ancient fault lines that have been dormant for millions of years suddenly reactivate. Regions that should be geologically stable are torn apart by secondary earthquakes as seismic waves bounce back and forth through the Earth's interior. 3 minutes after impact, something unprecedented begins happening to the atmosphere itself. The returning debris has heated the upper atmosphere to over 1,000 degrees Fahrenheit across the entire North American continent. Any dinosaur caught in the open experiences what can only be described as being inside a giant oven. The air temperature at ground level begins rising rapidly. Plants start to wither and die from the heat before they even catch fire. Water begins to evaporate at an alarming rate. The entire ecosystem is cooking from above. 4 minutes after impact, the first massive tsunami waves generated by the impact's seismic energy hitting the ocean floor begin racing across the Gulf of Mexico at 400 miles per hour. These waves are over 1,000 feet tall, taller than the Eiffel Tower, and carry enough energy to reshape entire coastlines. 5 minutes after impact, the atmospheric shockwave has traveled over 600 miles from ground zero, leaving a path of total destruction in its wake. Behind it, the landscape looks like the surface of an alien planet. Every tree has been incinerated, every body of water has evaporated, the very soil has been baked into glass-like fragments. Ahead of the shockwave, dinosaurs are experiencing the strangest phenomena of their lives. The sky is on fire, the ground is shaking continuously, a sound louder than thunder never stops. Strange hot winds carry the smell of burning rock, but they still don't understand that all of these seemingly separate disasters are connected to a single event that has already sealed their fate. The asteroid impact has now directly affected an area larger than Texas. Millions of dinosaurs have died in these first 5 minutes. Millions more will die in the next hour as the destruction continues to spread. The Mesozoic era is ending in real time, and most of its inhabitants don't even know it. In the next 55 minutes, we witness how a local impact becomes a continental disaster, and then a global catastrophe. This is the hour that determines which species live and which disappear forever. 10 minutes after impact, the returning debris from space reaches peak intensity. What scientists call impact ejecta is now raining down across an area covering millions of square miles. These aren't pebbles. Some pieces are the size of cars, heated to over 2,000 degrees and traveling at hundreds of miles per hour. Any dinosaur struck by one of these incoming projectiles dies instantly, but even more deadly is the cumulative effect of millions of these burning fragments hitting the atmosphere simultaneously. The collective heat they generate is equivalent to setting the entire continent under a giant heat lamp. Ground temperatures across North America rise to over 140 degrees Fahrenheit, hot enough to kill most dinosaurs through hypothermia alone. The few creatures that survive this initial heating are those that can burrow underground or escape into deep water. 15 minutes after impact, the massive tsunamis generated by the impact begin hitting coastlines around the Gulf of Mexico. Waves over 600 feet tall crash into what is now Florida, Alabama. These waves don't just carry water, they carry billions of tons of sediment, debris, and marine life. When they retreat back to the ocean, they carve new channels and leave behind deposits that will still be visible to geologists 66 million years later. Any coastal dinosaurs that somehow survived the heat and earthquakes now face walls of water taller than skyscrapers. Entire ecosystems are swept away in minutes and dragged back to sea when the waters retreat. 20 minutes after impact, the atmospheric shockwave reaches the Rocky Mountains, nearly 1,500 miles from ground zero. Even at this distance, the wave still carries enough energy to trigger avalanches and rock slides. Mountain-dwelling dinosaurs face a triple threat: cooking heat from above, earthquakes from below, and avalanches from the sides. The shockwave's interaction with mountain ranges creates complex weather patterns. Superheated air is forced upward, creating massive thunderstorms with lightning more intense than anything in Earth's previous history. But these aren't ordinary storms. The rain they produce is boiling hot and often acidic from dissolved rock particles in the atmosphere. 30 minutes after impact, something remarkable happens on the other side of the planet. Dinosaurs in what is now Asia feel the ground shake as the seismic waves from the impact travel through the Earth's core and emerge on the opposite side of the planet. The impact has literally rung the Earth like a bell, and the sound is emerging on the other side of the world. This demonstrates the truly global nature of the catastrophe. There is nowhere on Earth that remains unaffected by the impact. Even dinosaurs on the opposite side of the planet are experiencing earthquakes, strange atmospheric phenomena, and unusual animal behavior as the planet's entire system is disrupted. 40 minutes after impact, the firestorms ignited by the returning space debris have merged into continental-scale conflagrations. From space, North America would appear to be entirely on fire. Smoke and ash begin to rise high into the atmosphere, starting the process that will block sunlight for months or years to come. These aren't ordinary wildfires. The heat source isn't coming from burning vegetation, it's coming from the superheated atmosphere itself. Even in areas with little vegetation, the ground is hot enough to ignite anything combustible. Entire forests explode into flames simultaneously across thousands of miles, 50 minutes after impact. the atmospheric composition begins to change dramatically. The impact has vaporized enormous quantities of sulfur-rich rock from the Yucatan Peninsula, injecting billions of tons of sulfur compounds into the atmosphere. These compounds will eventually form sulfuric acid, creating acid rain that will acidify the oceans. Additionally, the massive fires are pumping unprecedented amounts of smoke and carbon particles into the upper atmosphere. This begins the formation of a global soot layer that will eventually block 90% of sunlight from reaching Earth's surface. 55 minutes after impact, the tsunami waves generated by the impact begin reaching the Atlantic coastlines of North America. Even though these waves have traveled over 1,000 miles from their origin, they still tower hundreds of feet high when they crash into the eastern seaboard. The waves continue across the Atlantic Ocean, carrying with them the story of the catastrophe. Marine life in the deep ocean experiences massive disturbances as these waves pass overhead, disrupting food chains and migration patterns that have been stable for millions of years. 60 minutes after impact, 1 hour later, the immediate continental destruction phase is complete. The atmospheric shockwave has crossed North America and is beginning to affect dinosaurs in northern Canada and Alaska. The seismic waves have circled the planet multiple times, triggering earthquakes and volcanic activity on every continent. The returning space debris has finished its deadly reign, but the fires it ignited continue to burn out of control. The atmosphere is filled with smoke, ash, and sulfur compounds that will have effects lasting for years. And the massive tsunamis are still racing across the world's oceans, carrying the impact's destructive energy to every coastline on the planet. In just 1 hour, the asteroid impact has killed an estimated 70% of all dinosaurs in North America. The survivors are those that happen to be underground, underwater, or in locations that provided some protection from the heat and debris. But their ordeal is far from over. The immediate destruction phase may be complete, but the long-term global effects are just beginning. The atmosphere is now so full of particles that it will soon block most sunlight from reaching Earth's surface. Global temperatures are about to plummet. The age of fire is about to become the age of ice. We now witness how the asteroid impact transforms from a regional disaster into a planet-killing catastrophe. The events of the next 23 hours will determine the fate of life on Earth for millions of years to come. 2 hours after impact, the massive tsunamis created by the impact begin reaching coastlines around the Atlantic Ocean. Waves 300 to 600 feet tall crash into what is now Europe and Africa. These waves have traveled over 4,000 miles from their origin and still carry enough energy to flood hundreds of miles inland. Marine reptiles in the Atlantic Ocean face a double catastrophe. First, the passing tsunami waves disrupt their environment and food sources. Second, the massive amount of debris and sediment stirred up by the impact begins settling in the ocean, choking filter-feeding organisms and disrupting the entire marine food chain. 3 hours after impact, something critical begins happening in the upper atmosphere. The enormous amount of vaporized rock blasted into space by the impact starts to condense and form tiny particles. These particles begin reflecting and absorbing sunlight before it can reach Earth's surface. At the same time, the global wildfires are pumping unprecedented amounts of smoke and soot into the stratosphere. This combination of impact debris and fire smoke begins to form a global shroud around the planet. Even though it's still daylight, the sun appears dimmer and redder than normal. 6 hours after impact, the tsunami waves complete their circuit of the Atlantic Ocean and begin affecting coastlines in the Pacific. Every major body of water on Earth is now experiencing massive waves and disrupted currents. Ocean ecosystems that have been stable for millions of years are thrown into chaos. The global wildfires reach their peak intensity. Satellite imagery, if it existed, would show the entire planet wreathed in smoke. The fires are so massive that they're creating their own weather systems, with fire-generated thunderstorms producing lightning that ignites even more fires. 8 hours after impact, the first measurable drop in global temperature occurs. The particles and smoke in the atmosphere are beginning to block enough sunlight that the planet starts to cool. This seems like it might be a relief after the intense heating of the first few hours, but it's actually the beginning of an even more devastating phase. Dinosaurs that survived the initial heat and fires now face a new challenge: finding food. The global wildfires have destroyed most vegetation across entire continents. Herbivorous dinosaurs begin to starve, and without herbivores, carnivorous dinosaurs soon follow. 12 hours after impact, day turns to night, but the night is unlike any in Earth's history. The sky glows with an eerie red light from the fires still burning across multiple continents. The normal stars are invisible through the smoke and debris in the atmosphere. For nocturnal dinosaurs, this disrupts their natural behavior patterns completely. The ocean currents, disrupted by the massive tsunamis, begin to change their patterns. This affects the distribution of heat around the planet and will have consequences for climate that last for thousands of years. 18 hours after impact, something unprecedented begins to happen with the weather. The massive amount of water vapor blasted into the atmosphere by the impact begins to condense into clouds. But these aren't normal clouds. They're laden with sulfur compounds that will fall as acid rain. The first acid rain begins to fall in regions closest to the impact site. This rain is strong enough to burn the skin of any dinosaur caught in it. Plants that somehow survive the fires and heat begin to die from the chemical burns caused by the acidic precipitation. 20 hours after impact, the global temperature drop accelerates. With so much sunlight blocked by atmospheric particles, the planet is receiving only 10% of its normal solar energy. In just 20 hours, global average temperatures have dropped by 10 degrees Fahrenheit, and they're continuing to fall rapidly. Cold-blooded reptiles, including most dinosaur species, are particularly vulnerable to this temperature drop. Their metabolism slows dramatically in the cold, making it even harder for them to find food or escape predators. Many dinosaurs that survived the initial catastrophe begin to die from hypothermia. What started as localized chemical precipitation near the impact site has now become a worldwide phenomenon. The rain is so acidic that it begins to dissolve limestone and other carbonate rocks, releasing even more carbon dioxide into an already disrupted atmosphere. Plants across the planet begin to die not just from lack of sunlight, but from chemical poisoning. The base of the food chain collapses simultaneously across multiple continents. 24 hours after impact, one full day later, the first day of the post-impact world ends with Earth transformed beyond recognition. The atmosphere is thick with smoke and debris. Acid rain is falling on every continent. Global temperatures have dropped 15 degrees and are still falling. Massive fires continue to burn despite the cooling temperatures. An estimated 75% of all large land animals are dead. Most of the survivors are small mammals that could burrow underground, birds that could fly away from the worst effects, and reptiles like crocodiles and turtles that could survive in water. The reign of the dinosaurs, which lasted 165 million years, has effectively ended in a single day. But the planet's ordeal is far from over. The particles in the atmosphere will continue to block sunlight for months or even years. The global cooling will intensify into what scientists call an impact winter, a period of freezing temperatures that will last for years. Over the next months, as temperatures continue to drop and sunlight remains blocked, the few surviving dinosaurs will face starvation in a world where plants can no longer photosynthesize. The mighty T-Rex, the massive sauropods, the armored ankylosaurs, all will disappear from the fossil record. But from this catastrophe, new opportunities arise. The small mammals that survive by hiding underground will inherit a world without dinosaur competitors. These tiny creatures, most no larger than modern rats, carry within them the genetic potential that will eventually give rise to elephants, whales, primates, and ultimately humans. The asteroid impact didn't just end the age of dinosaurs, it made the age of mammals possible. In the most violent day in Earth's history, the future was rewritten in fire, ice, and stone. As we conclude our journey through the most catastrophic day in Earth's history, let's explore what happened in the weeks, months, and years following the impact, and how this single event shaped the entire future of life on our planet. The impact winter that began on day one of the catastrophe lasted for years. With 90% of sunlight blocked by atmospheric particles, global temperatures plummeted by an average of 50 degrees Fahrenheit. Most of the planet experienced freezing conditions, with only a few tropical islands near the equator remaining warm enough to support complex life. Plants, unable to photosynthesize in the perpetual twilight, died en masse. Without plants, herbivorous dinosaurs starved. Without herbivores, carnivorous dinosaurs followed. The food chain collapsed from the bottom up in a cascading extinction that eliminated roughly 75% of all species on Earth. But life, as we know, finds a way. The species that survived possessed specific characteristics that allowed them to weather this global catastrophe. Small mammals could survive on minimal food by eating seeds, roots, and carrion. Their ability to maintain body heat through internal metabolism gave them a crucial advantage during the impact winter. Birds, being warm-blooded and capable of flight, could migrate to find food and shelter. Interestingly, only ground-nesting birds survived. Those that nested in trees were eliminated along with the forests. Crocodiles and turtles, with their slow metabolisms and ability to go months without food, survived in aquatic environments that remained relatively stable. In the oceans, the extinction was just as severe. The marine food chain, disrupted by acid rain and blocked sunlight, collapsed. Massive marine reptiles like Mosasaurus disappeared forever. However, smaller marine life forms, including early mammals that had adapted to aquatic environments, survived and would eventually evolve into whales and dolphins. Perhaps most remarkably, this catastrophe set the stage for the rise of mammals and eventually human beings. For 165 million years, dinosaurs had dominated terrestrial ecosystems, occupying every major ecological niche. Mammals remained small, mostly nocturnal creatures living in the shadows of their giant reptilian cousins. The asteroid impact changed everything. With the dinosaurs gone, mammals suddenly had access to ecological niches that had been closed to them for millions of generations. Over the following millions of years, mammals diversified explosively, evolving into forms that filled every available habitat. Some became giants, like the massive ground sloths and saber-toothed cats. Others took to the air, evolving into bats. Still others returned to the ocean, becoming whales and seals. And one particular lineage developed larger brains, opposable thumbs, and eventually the capacity for language, art, and science. The asteroid that killed the dinosaurs also made human existence possible. Without that catastrophic impact, 66 million years ago, dinosaurs might still rule the Earth today, and mammals, minus including our own evolutionary ancestors, might never have had the opportunity to diversify and evolve into the myriad forms we see today. Scientists continue to study the Chicxulub impact site in the Yucatan Peninsula, using advanced technology to uncover new details about this pivotal moment in Earth's history. Core samples from the crater reveal layers of shocked minerals, impact glass, and debris that tell the story of those first crucial minutes with remarkable precision. This research has implications beyond paleontology. Understanding how the asteroid impact affected Earth's climate and ecosystems helps scientists model the potential effects of future cosmic impacts or other global catastrophes. The Chicxulub event serves as a natural laboratory for studying how planetary systems respond to extreme disruption. Today, space agencies around the world monitor the skies for potentially hazardous asteroids. The lessons learned from the dinosaur extinction have motivated efforts to develop planetary defense systems. NASA's DART mission successfully demonstrated that human technology can alter the trajectory of an asteroid, something the dinosaurs could never have achieved. As we look up at the night sky, we're reminded that Earth exists in a cosmic shooting gallery. The asteroid that ended the age of dinosaurs was not the first major impact our planet has experienced, nor will it be the last. But unlike the dinosaurs, we have the knowledge and technology to see these threats coming and potentially do something about them. The story of the asteroid impact is ultimately a story about change, survival, and adaptation. It reminds us that even the most dominant and successful life forms are vulnerable to sudden, catastrophic change, but it also shows us that life itself is remarkably resilient. From the ashes of the greatest extinction event in Earth's history emerged new forms of life, new evolutionary pathways, and ultimately, the rich diversity of species we see around us today. The first minutes when the dinosaurs went extinct were the first minutes of our own evolutionary story. In those terrifying moments of fire and chaos, the future was rewritten. The age of reptiles ended, the age of mammals began, and the stage was set for the eventual rise of human civilization. So the next time you see a bird, the only surviving dinosaurs, remember that they carry within them the legacy of that catastrophic day 66 million years ago. They are living reminders of both the fragility and the resilience of life on Earth. And that brings us to perhaps the most thought-provoking question of all. could it happen again? The answer, unfortunately, is yes. Asteroids and comets continue to orbit our solar system, and Earth remains a target. The question isn't if another major impact will occur, but when. However, unlike the dinosaurs 66 million years ago, we have something they never had: knowledge, technology, and the ability to prepare. We can track potentially dangerous objects, we can model their trajectories, and we're developing the technology to deflect them if necessary. The age of helplessness in the face of cosmic catastrophe may finally be ending. The story of the first minutes when the dinosaurs went extinct is more than just ancient history. It's a reminder of our place in the cosmos, the precious nature of life on Earth, and the importance of protecting our planet, not just from human-caused disasters, but from the cosmic forces that have shaped our world for billions of years. From those first terrifying seconds of impact, to the years of darkness that followed, from the collapse of ancient ecosystems, to the rise of new ones, the asteroid impact that ended the Mesozoic era was truly the day that changed everything. It was the day the Earth reset, evolution took a new path, and the future of life itself was rewritten in fire and stone. Thanks for joining me on this incredible journey through the most important day in Earth's history. If you found this as fascinating as I did, make sure to like this video and subscribe for more amazing stories from our planet's incredible past. What other catastrophic events from Earth's history would you like to see covered? Let me know in the comments below. Until next time, keep looking up at the stars, but maybe with a little more respect for the power they occasionally send our way.